So, introduction to control systems training. Now, in this image, you can see that there are two types of industry images. On one side, I can see the petrochemical plant with its very identifiable fractional distillation columns, and on the other picture, I can see the power plant with its, with its boilers and everything. So I can, if anybody has any previous experience working with any of these, they can immediately see at the images and identify that which is going to be a power plant and which is going to be a petrochemical plant. So now if we move to the next screen, we can see that there is a food processing industry, and then we can see an example of an assembling industry. So why there, what we are trying to show by these two slides is that there are, although both the slides are actually showing manufacturing process, but there are two different types of process industries, right? So we'll move forward and learn about them. And anybody will have any question about this?
No.
All right. So the two industries that I was talking about are discrete manufacturing and process manufacturing, right? So the first image that we saw was a process manufacturing example. Extracting oil and gas from crude oil is a process. You follow steps in sequence and then you obtain your process variable. So it's a process that is used in power plant and oil and gas. That is why they are an example of process manufacturing. While discrete manufacturing is an industry in which you are producing finished product that are being assembled together by putting identifiable parts together to form your final finished product. Let's say, for example, let me move back. You can see the example of the automobile industry, or you can see aircraft being assembled here. So what is happening here is you are manufacturing finished products that are distinct items. A model of an aircraft, let's say Airbus 737, or a car, they are identifiable distinct items, right?
Right.
So what I want to say by this is that these items are distinct items which are easily identifiable and they can be counted. So what is happening is discrete products are being assembled in discrete manufacturing. Products are assembled using distinct items capable of being easily counted, touched, or seen. That what it means is that there are several parts that are assembled together to create your final finished product. And this final finished product is very unique, very identifiable in their own way. You can identify a car by its model, right? Although there will be several cars of that model, but that will have its own identity. And at the end of its life cycle, any finished product of discrete manufacturing, at the end of its life cycle, you can break it down and strip it for parts and reuse them later on, either in any further manufacturing or to manufacture something else, right? So discrete manufacture is an industry term for the manufacturing of finished products that are distinct items capable of being easily counted, touched, or seen. In theory, a discrete product can be broken down at the end of its life cycle. So its basic components can be recycled. An automobile is a product of discrete manufacturing. So this is the same example that I just used, right? Then there is process manufacturing. In process, you're actually trying to follow a recipe or a formula. You're following some steps. You are subjecting your raw material, your input material, to some kind of steps, some recipe. You are heating it, cooling it, you are crystallizing it to obtain your final finished product. Unlike discrete manufacturing, at the end of its life cycle, the finished product life cycle, you cannot break it down to obtain the raw material again, right? You can't break it down to and use it for recycling some of its components. Like if at the end of the life cycle of an automobile, at the end of the life cycle of an automobile, you can break it down, strip it down for parts, and reuse parts in further manufacturing of some other product. But let's say if you take an example of process industry, you are producing, let's say, sugar from sugar cane. You can't break down sugar again once you have obtained sugar from that sugar cane. After following the process, you can't break down sugar to obtain sugar cane again, right? So in process manufacturing, the product is created by using a formula or recipe to refine raw ingredients, and the final product cannot be broken down to its basic components at the end. So process manufacturing industries include examples such as chemicals, food and beverage, gasoline, paint, pharmaceutical, fertilizers, so power plants. Any questions about these?
No.
No.
Right.
No.
Right. So now we get to some pointers about discrete manufacturing, right? So discrete manufacturing is all about assembling things and making things that are exact, which is to say that if you're manufacturing something, right? Let's say you're building an automobile, you're building a bike, or maybe a car, or maybe a pickup truck. The thing is that you are putting together some components, some parts to create a finished product, but although you're making several of those, but they're all going to be exact. If, let's say, it's a model of a car, then that model is always going to be exactly similar, right?
Yes, sir.
Right. So the products are typically manufactured in individually defined lots, right? So let's say there is this one manufacturer that is producing a car as well, a pickup truck as well, maybe some other vehicle as well. So they are going to do it in defined lots. They will have this production line for that product, maybe another production line for their trucks, maybe another production line for something else, right? The sequence of work centers through production varying for each one of these. So although you have to follow a sequence, but the basic outline will remain same, but there may be some separate steps that will, differentiate the whole lines from them. Thus, in discrete manufacturing, the product is made by sequential steps made in the same process or by the same craftsman. So, although there will be a difference in manufacturing of these defined lots, like if you are building product A and you are building product B, although there will be a variation in the steps of both, but as long as you're going to build product A, you'll follow the same process in the same way, right? Discrete manufacturing based on the production orders and product change frequently from order to order. So we can say that some items are more desirable in some seasons while some are not. You can say some items are much more in summers rather than in winters. In winters, it may reverse. The products that were not in demand in summers are now in demand. So that way, your production is going to be based on lots of factors, the types of orders that you are receiving in the region in which you are operating or producing. So discrete manufacturers are making a finished good that may have screws, nuts, handles, etc. that can be taken apart and used on something else if need be. So what it means is that, as I said earlier, you have smaller parts that you put together to create a final finished product. So you can take them apart or you can use the same thing on something else as well. Manufacturers produce different models of cars, but sometimes if they have 2 or 3 types of sedans, they may have the same type of handle, the same type of door handle, right? So you can use the parts either by taking them apart from a finished product or entirely on a different product line. So in discrete manufacturing, the manufacturing floor works on shop orders to build something. The individual products are easily identifiable. This I have been outlining since the beginning, that the products are identifiable. A brand and a model are easily identifiable, right? So any questions regarding these points?
No.
Nope.
So let me move forward. Now we come to the few points on process manufacturing. So process manufacturing is when you have a product that requires a set of processes to be finished. Each process in turn has certain needs. So you have to follow a few steps. You have to follow those processes, and at the end of each step, you obtain some product, which you then further subject to another process and keep on refining until you get your final finished product that you were trying to obtain. Thus, each process is separated from the other while planning and setting the manufacturing requirements to ensure that the individual processes are better controlled and maintained if they are dealt separately. Process manufacturers build something that cannot be taken apart. Technically, you can take the mix out of the container and reuse the container, but you can't take the ingredients out of the finished good. So that means that the same example we can use, like you can't break down sugar to obtain sugar cane, or you can't break down your energy that you produced, your power, to break down and obtain the gas or the coal that you use to produce it, right? So this makes process manufacturers process, recipe, or formula based, right? In process manufacturing, you can't tell the difference between one product and another. So what they mean by this is, if we go to the point of discrete process, the finished product that you are building is clearly identifiable. Yes? Yes?
Makes sense?
Yes.
Right. So you can identify the model and the brand of the car, right? You can clearly separate them, that this is brand A, model X, this is brand B, model Y, right? But in process manufacturing, you can't do that. You can't say that this gasoline that I'm getting is either from manufacturer A or B. You can't just look at the container and tell whose gas is it going to be, right? So any questions regarding process manufacturing points?
No.
Nope.
Anyone?
Nope. Nope.
Right. So let's move forward then. So this slide is a slide example of discrete manufacturing, a car assembling process. So what we can see here are a few steps that once that are executed in a sequence to assemble a whole automobile, right? So a few steps may be like, somewhere you may be doing one step before the other. So it's a generic process. It doesn't have to be exactly similar, but the example is put in place to explain that in discrete manufacturing, you will have your steps outlined very clearly, and you will be executing them step by step, putting together different smaller parts to create your whole final finished product, right? So we can see that first there is a chassis assembly. So you're putting together your chassis, then your axle entire assembly is attached to it, then your engine assembly is put in your chassis, your gearbox assembly is then attached to it. So now you have a working axle, engine, and gearbox. Your transmission is ready, right? Then you put in your radiator assembly. Then seats are assembled. Once you have done these steps, you put in together your electrical wirings and electrical assemblies, your ECUs, your sensors, etc. Then the main body assembly is being done. Main body to say that you put in your boot, you put in your bonnet, then windshield assembly and other glasses are put in. Later on, they have used the example of wiper assembly, door assembly, then the final finishing trim assembly. You put in together your door trims and other small plastic items. Then once all this has been put together, you subject the vehicle for a final inspection, and if it passes the inspection, then you get your finished car, right? Anybody who has seen this process?
No.
No.
No. Right. Well, you can use this as a generic example of this now. Right. So any questions based on this?
No.
No.
Okay.
So far, so good.
What? I'm sorry. Someone said something.
No questions.
Right. So
No questions.
Let me move forward, right? Okay. So this now is an example of a process industry. The process manufacturing in oil and gas refinery. I am sure that most of us can recognize the image there. It's a fractional distillation column. How many of us actually remember this?
Me? I do. No, but
Right? So most of us can actually recollect that this is a fractional distillation column. We must have studied it at one point or the other in our educational background. So what we can see here, it's a column, right? And as the name suggests, fractional distillation column. So it's a distillation column in which your crude oil is being input from one side, right? And it is going to be distilled to obtain different products out of the raw material, that is your crude oil. So what is happening here is, you guys can see my mouse pointer, yes?
Yep.
Right. So you can see that there is this here is your crude oil inlet. This is your furnace where you're actually, when the crude oil is flowing through it, you're heating it, right? So once this heated crude oil flows into your fractional distillation column. Now this fractional distillation column will have different temperature ranges at different levels, right? Right?
Right.
Yes.
Yes, sir.
Yeah, guys, please interrupt me if there is something that you want me to repeat, or if there's something that you want more explanation of, or is not clear, right? So once this heated,
I
right.
think at this level, we don't ask a lot of questions because it's something like a review that we already did.
Yeah.
So it's still basic, so it's not really
I know.
for me.
Right, I know. But to consider the whole group, we don't know that maybe there may be someone who may have a question. So as a duty, I have to ask that if somebody has a question, right? So we'll see.
Yes, sir.
Right. So when the heated crude oil enters this fractional distillation column, right? Because of the heat, most of the crude oil is then converted to vapors and all. So it rises above in the fractional distillation column, and these fractional distillation column, these fractions, all of them have a different temperature range that is being maintained there. So while the vapor or the oil rises there, you can obtain different products at their own different temperature ranges. Although it's not such a simple process, it does not only follow the only steps that I'm saying. There is a lot of other factors there as well. There's a whole lot of chemistry going on. You're putting reagents and all. But to understand it at this process, yes. So what is happening here is fractions increasing in density and boiling point are settling down at the bottom, right? But fraction decreasing in density and boiling point, the vapors, they are rising above, right? So you can, now that you have different temperature zones, they are going to cool off at different temperature zones and turn into your process variable, your liquid. So from there, in a gas form. So there you obtain them. So at the top you have C1 to C4, which is your gas. So you use this for liquefied petroleum gas. This is obtained at, let's say, roughly 20 degrees centigrade. Then from C5 to C9, you're obtaining naphtha, which you are going to you're going to take ahead into a naphtha cracking unit, and you're going to use it to create your fertilizers and chemicals. This is obtained at 70 degrees centigrade. Now these are rough estimates, right? Then C5 to C10 is your petrol or gasoline. So this is gas for vehicles. This is at 120 degrees centigrade. C10 to C16 is your kerosene or your paraffin oil. This is your air grade fuel. So jet fuel, paraffin, wax, lighting and heating oil. This is obtained at 170 degrees centigrade. C14 to C20, these are your diesel oils. So you obtain them for heavy diesel engines like trains and all. So this you get at 270 degrees centigrade roughly. C20 to C50 is your lubricating oil. You get your lubricating oils, waxes, polishes. Basically, the example would be engine oils or wax for your cars, right? So the raw material, the major component is obtained from this C20 to C50. Then C20 to C70 is your fuel oil. This is for very, very big diesel engines, like you have what you have in your factories or what you have in your steamliners, your big ships. 600 degrees centigrade. And C70 is your residue. You get bitumen for roads, you get coke. So if you have a delayed coker unit, you can refine it more and obtain the coke directly that is being used for many, many more purposes. Any questions regarding to this slide?
No.
No.
Right. Right. So when we look at both the above industries, it becomes clear that a lot of complex processes have to be done with accuracy and precision in obtaining the finished products. Yes. So it is going to be a labor-intensive task if it's manually operated, right? Also, the risk when manual labor are in the vicinity area of production also increases. So the risk for manual labor also rises in case of process industry due to usage of chemicals and conditions of parameters which are controlled. Although, which is to say that it is not that discrete industries do not pose risk there as well. There you have robots that are welding stuff. You have robots that are cutting. There are shredders. So a chance of an injury is just as much present as there would be in a process industry. So due to some of the above mentioned factors and other such factors, industries have long been looking for alternative techniques wherein the process can be done accurately, resulting in better quality of products as well as providing safe work environment. So what the idea is that you want to keep your human manual labor away and out of harm's way while producing more product of better quality, right? So this requirement actually is what led to the replacement of humans with various control equipments to control the process. This is called as industrial automation, right? So I hope everyone would agree with the points that we have, and I don't think there must be a question on this, but if there is, you can please ask. Right, so I'm moving forward, right? Right. So industrial automation. So this word is made. This is made up of two words, right? Industry and automation. Now, industry is something that is a group of manufacturers. Any group of manufacturing producing the same type of product, you can align them as that industry, like automobile industry, right? Oil and gas industry, fertilizers and chemical industry, right? Power industry, energy sector. So an industry is a group of manufacturers or businesses that produce a particular kind of good or service, right? Now, the second word, automation. So the word automation is derived from the Greek words auto and matos, where auto means self, while matos means moving, which means that anything that is self-operating, self-dictating, or a mechanism that is moving by itself can be termed as an automatic and will have the domain of automation. Industrial automation can be defined as the use of technologies and automatic control devices that result the automatic operation and control of industrial processes without significant human intervention and achieving superior performance than manual control. Right?
Yes.
Any questions on this? Although I know that there won't be much. Right. So now we come to an actual example of it. So to understand the above definition better, let us look into an example of a process. So in most of the industries, there is a requirement of hot water for various purposes. In our case, we will look at supply of water to a number of cleaning stations where the water temperature needs to be kept constant in spite of the demand, right? So for the solution of this, we have put in together a process which you can see on screen. Now, is there anyone who can just look at the image and try to explain what is happening here?
Oh, I can try.
Right.
The cold water come in where you say in, and there's a heater element. I don't know if it's a heat exchanger or what boiler, but there's a heat element who heat the water before it goes to the tank. And we have a thermometer, which is basically a control element. We have a valve. Also, the hot water, when it's in the tank, there's a steam will go out through the valve and in the, I don't know, in the process. So the valve is there to be open or shut. It can be shut manually because I see the hand of a man.
Yeah.
So basically, for me, that's the understanding. Basically, the end process is to produce steam that is used maybe to turn, I don't know, maybe engine or to do anything. So
yes,
that's my understanding.
Let me explain that now. So by the diagram, we can see that there is a heat exchanger that is being put in place, right? This is your heat exchanger where you have a cold water inlet and you have a hot water outlet. This being your thermometer that is being observed by a manual operator. This is your heat exchanging variable, right? These are your steam line pipes. So they are carrying hot steam and this is carrying your inlet water. So this here is your heat exchange happening and you're heating the water by the steam flowing in the pipes, right? So when your temperature, so you want hot water at the same temperature, right? So this operator here will be manually observing this thermometer, right? To see that the temperature remains in the ranges that are approved for it, right? The hot water temperature ranges. And whenever the temperature starts to fall below the range, what this manual operator will do is it will open this valve and let more steam flow in so that the water heats up and remains in the range that we want it to be. Then whenever the temperature increases beyond, it's going beyond the range of where we want the temperature to be, then this manual operator, after observing the range in thermometer, will close down this valve and reduce the flow of steam to heat exchanger to keep the water cooler and in the range that we want it to be, right? Let's see the process. Steam and cold water are fed into heat exchanger where heat from the steam is being used to bring the cold water to the required working temperature. A thermometer is used to measure the temperature of the water from the process or exchange. Now, how would you maintain the water at the defined temperature irrespective of the changes in the demand of water at outlet? I just explained how we are going to do that, yes?
Right.
Yes.
Right. So if the temperature has to be maintained, there should be a constant monitoring of the thermometer and adjustment of the steam flow, which is what our manual operator is doing there. So this can be done by two ways. The manual one, as we saw in the image earlier, or the automated control. Now let me move forward and show you the automated control. Now let's just first read about the manual control. So in manual control, the temperature is observed by operator who adjusts the flow of steam into heat exchanger to keep the water flowing from the heat exchanger at constant set temperature, right? We just discussed that, right? But in automatic control, you take out the manual operator from the equation. You put in the output variable now is being sensed by the amplitude of the output parameter and is compared to desired or set level, which we sometimes call a set point. And an error signal or a reference signal is sent to the controller, and a corrective signal is then sent by the controller back to keep it at the desired level. So what basically it means is that now in automatic control, you're going to put in a controller there, you're going to put a sensor there. Now this sensor, your temperature sensor, will constantly be monitoring the temperature of your hot water coming out, right? So whenever this hot water temperature falls below a range, now the sensor is sending the temperature constantly to your controller as an input, right? So when the temperature goes below range, this input will then be, the controller will receive this input and then evaluate it as per the logic that is written there. So if it is below the range that is acceptable, this will mean that the controller will take this as an error signal and then will take a corrective action upon it, which would be that if the temperature is lower than what we want, then it will open the steam inlet, and if it is more, then it will close the steam inlet, so further increasing or decreasing the heat exchange capability of our heat exchanger and thus maintaining the temperature of the water. So in our case, steam, a temperature sensor, is attached to the outlet pipe. It senses the temperature of the water flowing. As the demand for hot water increases or decreases, a change in the water temperature is sensed and converted to an electrical signal, amplified and sent to a controller that evaluates the signal and sends a correction signal to an actuator. Actuator here, steam inlet valve, right? The actuator adjusts the flow of steam to the heat exchanger to keep the temperature of the water at its predetermined value. So this is what I just explained, but in a simpler term, right? Any questions?
No.
Right. So we can see that the image here now. So this is how the manual control to automated control changes occur in the industry. Thermometer is replaced by sensor, which produces electrical signal. The human response is now being provided by a controller. So you can see now we have replaced it by a controller which is receiving an input from the sensor and providing an output to your actuator of the valve, right? So this is how the manual, we already have read this. We move forward. Now we come to the point of advantages. Now, what are the advantages of industrial automation, right? Now, before actually we move into this, I would like to have a discussion. I would like to know from you guys what you think are the advantages of industrial automation. Grateful to all the patient listeners as well. Thank you. Very nice doing this session for you. Let's hope we meet in the next class. Right?